this is the in-class review we did Friday, and here we go with some of the answers. So the first two is because the very first lesson of this unit we went over naming polynomials and different parts like the coefficients, the constants, etc. Okay, so the first one says degree of polynomial. So the degree of the polynomial is the highest degree. Okay, and by degree we are referring to the exponent. So I go to my polynomial given, and these are my exponents. This one doesn't have one. And then I notice that it is in descending order, 4 and then 2. So this is written correctly. And the highest one is the 4. So the degree is 4. The terms, okay, remember they're separated by plus or minus. This is 1 term, 2 terms, 3 terms. The name is kind of like they have a first name and a last name. The first name would go from the degree of polynomial. So if it's degree 4, okay, I give you the cheat sheet here. Degree 4 would be quartic. So we would write quartic. And then it has 3 terms. So we've been talking about monomial, binomial, trinomial forever for these past few weeks. So that one we should have already known by memory. Okay. These are the ones that you will hear the most in our subject, so we should be familiar with those. We keep talking about linear and quadratic. Make sure you kind of briefly study the other ones. Leading coefficient. This is the number in front of the first variable when it's in order of degree. Okay, so number in front of first variable. Okay, and it has to be in order of degree. And we already know that this one is in order. In order means descending order, so 4 and then 2 and then nothing, so we're good to go. Okay, the number in front of the first variable, so this is the first variable here, or the first term, also. I should put term, not variable. Okay, so this right here would be my leading coefficient, the -7. The constant term is a term that does not have any variables. Okay, in this case, it would be -7 as well. This one would be 5, the degree of a polynomial. It is in good order, 5 and then 2 and then nothing, so it's in correct order of degree. Terms 1, 2, 3. The name, this would be quintic because it's degree 5. And trinomial because it has 3 terms. Leading coefficient would be the number in front of that first term variable. So this is my first term right here. And the number in front of that first term, which should be there, but there's no number. So whenever there's a number, it's a 1. And the constant term is a term that does not have a variable, in this case positive 4. Okay, this one there's no other way around it but to memorize the vocabulary. Remember that at the beginning of this unit I gave you a vocabulary organizer that has all these terms, so please take a look at it right before you take the test to go ahead and review. Okay, this one was actually an exit ticket that you took in class and we're just re-reviewing it. So here the keyword would be perimeter. So we're doing the perimeter of this. That means that you add all the sides. When I'm adding polynomials, I have to add the ones that have like terms. Okay, so for example, these that I'm highlighting right here have x to the 3rd, so they are like terms. Okay, so that I can add together. The ones that I'm highlighting in yellow have x squared, so that means that they are like terms. This one right here doesn't have a number, so it would be a 1. And the ones that I'm highlighting in green are constants, and they are like terms as well. Okay? When I am adding, I leave the variables and the degrees, the exponents alone. All I do when I add all sides is just the coefficients. So add coefficients of like terms together. We do nothing to the variable or the power. We leave it as is. And excuse the announcement if they're going to announce something. Okay? So now I have all the ones highlighted in pink. So 5x to the third, 6x to the third, and 10x to the third. Okay, I can add them together. And I would get 21x to the third. Okay, so those are the colors for the pink. Okay, for the ones in yellow, which are the quadratics, right, the x terms, x squares, I have 3x squared, and I have 1x squared, and I have 2x squared. These are all positive and negative. Okay, so here, quick mental math, I know that these two are opposites, so I can cross them out and just add the middle, or you can, add them together. When you add them together, you would get 4x squared and positive 4x squared. Okay, and then I will add all the constants together, so 18, 1, and these are all positives, negative 9, and negative 20. So when I do that, I will get negative 10. So this together is my answer. 21x to the third plus 4x squared minus 10. That's how we get the perimeter. Okay? This was like your do-now problem today. Right, on the next page, it asks me which expression represents the area of the rectangle. So here my keyword is area, and obviously rectangle. So when I have the area of a rectangle, it will be length times width. So this is length, this is width. So I'm going to have to multiply those two together. This already represents the area, this expression, and I know this one wasn't too clear, but I wanted you to actually multiply it and solve it. So we just did this, you were right, that is an expression that represents the area, but I also want you to solve it here. So I apologize for that not being too clear. So here you can do distributive property where you multiply the first term by the first and the second term of the second binomial, and then the second term of the first binomial by the first, and then the second term of the second binomial. If you do that, that's okay. Most of the time in class, I have used the tabular method. So I will do that right here, step by step. So x plus 2 is a binomial. That's why I have a 2 by 2 box, because 2 by 2. And then I will multiply here to get the answer. So what goes here, I would have to multiply that and that. Okay? So this times this will give me this. So x times, and this will be a 1. 1x times 9x gives me 9x squared. Okay, to get this bottom one, I have to multiply that and that. So 9x and 2 to get me to that right here. So 9x times 2 would be 18 positive x. So 18x positive. Okay, this one up here would be this times this. So 1x times 7 will be positive 7x. And lastly, this times this will give me the constant term. So 7 times 2 is positive 14. Everything inside the tabular box is my answer to this multiplication. This is the product. Okay, I'm going to go one step further because I noticed that these two are like terms, the linear terms, and I'll just combine them. So I'll have 9x squared, this one right here. These together come up to 25, x, and then the constant, which is 14. So that would be the area. Since they didn't give us any units, I don't know what units they are, so I'll just leave it like that. For this one, I know we had a little bit of trouble here with question number 5 during class. Here you are multiplying these two binomials together. When you notice that we have, remember in class we called it fraternal twins. When they are fraternal twins, that means like the terms are the same, but one is plus, one is minus. This is a difference of squares. So it's a difference of squares. That means that A minus B times A plus B, like in this case, they are the same first and second term except the minus and the plus. In the formula, where we can use that shortcut that we talked about during class when we did special products, okay, it says, you know what, you don't have to do all of this box or all of this distributive property like we multiplied this one. On this one, because they are the special case of difference of squares or fraternal, like we call them fraternal twins in class, all you have to do is this to get the answer. So I would have to square the first term and square the second term and put a minus in between. So 2x squared would be 4x squared, because 2 times 2 and x times x. And then 5 squared would be 25. So this would be my answer. Okay? If we do not use a formula and we're like, I don't know about that, I'm going to just multiply with my tabular box and call it a day, you can also do that. And with fraternal twins like these, you'll notice the difference of squares. The middle terms will cancel out. So you have 4x squared, you have negative 10x, positive 10x, and negative 25. So these two will always cancel out, equal to 0. And guess what? You get the same answer for x squared minus 25. Okay? I just wanted you to see it with the formula, this being the formula. Alright, so for number 6 and 7 is also tabular multiplication. Okay, when we get this right here, you're going to multiply that times that. W times W would be W squared. And then that's it, P. There's no other P, so P. W times negative 4 goes here. W times negative 4, so that would be negative 4W. Over here would be 3p times WP. So remember, all of these had a coefficient of 1 if you don't see it. So it's not necessary. This one has a 3. So 3 times 1 would be 3. And then we can do the variables. P times P is P squared, and then we have that W. And over here, 3 times negative 4 is negative 12, and then we have that P. Don't forget about the P. In this case, we look at it, there is no like terms whatsoever. All of them are different. They don't have a matching variable with the same exponent. None of them do. So then you just write it out as is for your answer. Okay, and then you will be done with that. All right, so for number 7, here they tell you that each little part here, this is a sketch of an office, and each portion is a different private office, and each has its own measurements of length and width and the area. So they've done everything for you. And now they want you to represent a polynomial that represents the entire large office, so all of it. So I want to know what the area of all of this together is. So if I want to know all of this together, I'm going to add each individual area of each of those individual offices, and then that would be the area of the whole office. So basically, this looks like a tabular box. This times this is that, this times this is this, etc. So I'm going to combine like terms here. These two are alike, and then these two are also alike. This, there's no like terms, that there's no like terms. So m to the third, these together. Remember that we are adding. When we do this and combine like terms, we are adding. Okay? So when we add, we don't do anything to the variables or the exponent, we leave them as is. So when I get the result, I'm still going to have m squared. So negative 2 and negative 3 would be negative 5m squared. Here I'm only adding the coefficients as well, they're both m's. So it's going to be 11m, and then the negative 10, which is the constant term. Okay, so this ends the first portion of your review. I'll do the other portion in a different video.